In this lesson, we're going to look at something called volume. That's not the same as the volume that comes out of speakers and televisions. It's really the amount of space that a 3D shape takes up. Now, this was actually discovered by a man called Archimedes, which you have seen. Some of you looked at him in the famous mathematician project. He was an amazing man that invented different things. But the way he came up with the idea of volume is he got into a bath that was full up, and what happened when he got into the bath is water came over the edge and went out, and he realised the amount of water that came out was the same as his volume. So the amount of him that was in the water had chucked the same water out. He took up the space of the water basically in the bath, so there was no place for the water to go but out with it. So he realised that he took up a volume of the amount himself, and the water helped him to show that. So the basic definition of volume is the amount of a space, the amount of space a shape takes up. In the case of him, it was the amount he took up inside the bath. Now we've got different units for measurements of volume, different to just measurements of length. Length is millimeters, centimeters, meters, and kilometers, etc. And area is millimeters squared, centimeters squared, meters squared, and so on. But when we talk about volume, because we're in 3D, we need to talk about cubes. So it's cubic centimeters we talk about. Now, cubic centimeters are like this. You've probably seen them in primary school. These wee cubes are 1 centimeter wide, 1 deep, 1 high, and they are denoted with this notation here, 1 centimeter with a wee 3. I always find it easy to remember this in terms of it's a 3-dimensional shape, and we put a 3 up here, as opposed to area is a flat 2-dimensional shape and you use a 2. Okay, so to work out the volume of different shapes at this level, we're not going to talk about curved shapes like spheres and cylinders. That will come later in maths. At the moment, we're just going to talk about building cubes up. So if we look at this first shape here, we've got 1, 2, 3, 4, 5, 6, 7, 8. So we could say that the volume of this shape, if each one's a centimetre cubed, would be 8 centimetres cubed. It's just a case of counting the shapes. Or counting the cubes, sorry. And the next one, if we count them, 1, 2, 3, 4, 5. And there's 5 on the other side, so that would be 10, and 11, 12, 13, 14, 15, 16. So that would be 16 centimetres cubed. Okay, a few harder ones. So we've got a bottom layer here of 1, 2, 3, 4, and another 4. So that would make 16 in the bottom. 17, 18, 19, 20, 21 centimetres cubed would be the volume of that shape. Again, on this side, we'll do the bottom first. 1, 2, 3, 4, 5. And 1, 2, 3, 4. So it's 4 rows of 5. So that'd be 20. And then 1, 2, 3, 4, 5, 6. 26 centimetres cubed. Right, we're now going to look at cubes and cuboids. I mean, there must be a better way than just counting all the cubes here to get this larger shape. So what we can tend to do is we tend to work out how much is in the bottom layer by doing 1, 2, 3, 4 and 1, 2, 3, 4 wide. So it would be 4 times 4 to get the number of cubes in the bottom. And then you've got 4 layers of that, 1, 2, 3, 4. So you need to times it by 4 again. And this would give you 16 times 4, this bit would come to 16. And then you could set a sum out for that, but it would be 64 centimetres cubed. So this is a quick way to work this out. And eventually what we get to the point is we get a volume formula. So instead of having loads of cubes, we can actually just measure the sides. And what you're essentially doing here is you're doing the length of the shapes. Imagine there was 6 cubes there. I know we're in meters here, but imagine there was 6 meter cubes. And then there was 2 along here, then that would be 6 times 2. And then you would times that by 4 levels of that. So 6 times 2 times 4. Now we call this long bit the length, just like in a rectangle. And this bit is called the breadth, again like a rectangle. We've now got this new measurement which is called height, which makes sense because it's gone up into the air. So a formula we're going to use from now on is volume of a cuboid, in this case, is length times breadth times height. So that would be 6 times 2 times 4. Now do this bit first, 6 times 2, which is 12. Get your answer of 12 and times it by 4, and that would be 48 meters cubed in this case, because we're dealing with meters. If these were all centimeters, it would be in centimeters cubed. So this would be a way of looking at it in terms of what we have. So the bottom layer there, what was it, 6 long and 2 wide, so it would be 6 by 2. You can see there's 12 there, and then I think it was 4 high, wasn't it? So we put 4 levels of this in. So we 1, 2, no, not straight, but that doesn't matter, 3, 4. That would be how we'd be doing it. 6 times 2 and times that by 4. Okay, just to finish the lesson off, we'll try these 4 examples here. Again, I don't mind if you use a calculator for these ones because there's some decimals down here, so we can get our calculator and type them in. But what we need to do in each case is make sure we write the formula down, then put the numbers in, and then give our answer at the end. So volume equals length times breadth times height is your formula each time for all these cuboids. And we're going to do 18 times 5 times 9. So we're going to write that in 18 times 5 times 9. Just type it into your calculator and you should pop out 810 centimeters cubed. Just double check that yourself. Next one, write the formula out, line up your equal signs, put the numbers in. 9 times 1.5 times 6. We notice this time we're in meters here, so we'll give our answer in meters cubed. Okay, 2 to go. So write the formula out again, and then put your numbers in. So it's 0.5 times 1 times 3.4. Now, it actually doesn't really matter which way around you've got these. It's good to put length and then breadth and then height, but multiplication doesn't matter. So 3 times 4 and 4 times 3 are the same answer. It doesn't really matter what way around, but try and put them as length and then breadth and height. But ultimately, if you didn't, it wouldn't matter. So your answer here is 1.7 centimeters cubed. Basically, you're doing 1 times that and half in your answer. So it's really a half of 3.4. And the last one here, put your numbers in. 3 times 5 times 13.6. Get your answer of 204. Make sure you put your units of meters cubed in.